Hi, welcome to TremorCon. Today I'm going to be talking about Google Cloud Storage and PubSub connectors for Tremor. A little bit about me. My name is Jigyasa. I recently graduated and will soon be starting as a full-time software engineer. This talk is about my project and experience contributing to Tremor as a part of the LFX mentorship program by the Linux Foundation. So my project was to add support for the GCP suite of APIs to Tremor as connectors. More specifically, I worked on adding the GCS and PubSub connector. We're going to be going through the introduction of the project, the implementation details, which I try to make as detailed as possible, walkthroughs and examples, and some use cases of the project. So before we get into the details of the project, let's first understand what a connector is and what all it involves. So connectors serve the purpose of sending events to and receiving events from the outside world. A connector can be an event source, also known as an on-ramp, or an event sink, also known as an off-ramp, or both. So a source, or also called the on-ramp, specifies how Tremor connects to the outside world in order to receive from external systems, whereas a sink or the off-ramp specifies how Tremor connects to the outside world in order to publish to the external system. So that's where the difference is. Sources are helping in receiving from the external systems, and sinks are helping in publishing to the external systems. So this is a brief explanation of what we saw in the last slide. You could say the yellow box here is Tremor. The incoming arrow is the source because it's receiving from external systems, and the outgoing one is the sink. It's publishing to the external systems. So now let's look at the Google Cloud Storage connector. So the GCS connector is nothing but a linked GCS sink that can issue the following basic GCS operations via Tremor, which are as follows: the listing all the buckets that are there, listing all the objects in a specified bucket, creating a bucket, inserting an object to a bucket, fetching an object which involves fetching all the details of the object, downloading an object, deleting a bucket, removing an object from a bucket, and all of that. So that means you can now store events in GCS through Tremor, delete them, view them, and do more stuff. Now, since it's a linked GCS sync, you'd also be able to see the response that's received from GCS when linked is set to true. Okay, let's come to the implementation of the GCS connector. For the implementation of the GCS sync, what all do we need? We require a client that can make requests, right? So for that, we use a request crate that provides a convenient high-level HTTP client and a few more things like the JSON method helper, storing and sending session cookies, etc. So apart from that, since we are using a service account, we need a mechanism for the authentication of our client to be able to perform the task. So for that, we use another library called gauth that is specifically for GCP service authentication and works by providing auto-renewed tokens. All you need is a service token JSON file and an environment variable called Google Application Credentials that points to the path of this file. On Google Compute Engine, it fetches the credentials from the metadata server. We can come to this again in the walkthrough as well. Next, we need the request endpoint. So because you all might know that APIs work using requests and responses, right? So when an API requests information from a web server, it will receive a response. So the place that API send requests and where the resource lives is called the endpoint. Once we have the client, we need the request endpoints or the URIs we can use to access cloud storage. So for example, if you look at the slide, the request endpoint for uploading an object to a GCS bucket looks something like this, which specifies where exactly would the object be uploaded. Uh, yeah. So, so for example, if you're uploading an object to a bucket, you'd need the URL of where exactly would that object go. Okay, let's come to the walkthrough guide. To get started, you need a service account on GCP and you will need a GCP PEM file for certificates authentication and a service token JSON file. So I have also explained the process of getting the service token JSON file in my blog, the link to which is in the slides as well. All you need to do is set the environment variable Google application credentials that will point to a valid non-expired service account token JSON file. For the setup, you need an outbound trickle file for sending the events to GCP, an inbound trickle to receive. You might also want to refer to the Tremor query language in the Tremor docs to be able to understand this better. Then we need a YAML file that shows the entire config, which includes the on-ramp, off-ramp used, as well as the bindings and mappings. So an example of how the GCS sync can be configured in the YAML is as shown. The supported preprocessors, postprocessors, and codecs can be configured in the YAML, and you can find the details of it in the docs. In the config, you can set up something like receiving a JSON on std in, then sending it to Google Cloud Storage Service, and you can also send it to std out, then writing the response that's received from GCS to std out by setting link to true. So you can also refer to the blog for a complete example of setting up the YAML. Some examples of what the request should look like are as follows. For uploading an object, the event should have the format as specified. A JSON object that states the command as upload object. Then you need the bucket name, the object name, and then the actual object that has to be uploaded. Similarly, we have for fetch object, and you can find more examples in the docs definitely. Now, let's come to the Google Cloud PubSub connector. Okay, so for those of you who are not aware of Google Cloud PubSub service, PubSub enables you to create systems of event producers and consumers, called as the publishers and subscribers. So publishers communicate with subscribers asynchronously by broadcasting events rather than by synchronous remote procedure calls, which we have seen before. So publishers send events to the PubSub service without regard to how or when these events will be processed. PubSub then delivers events to all the services that need to react with them. If you now look at the diagram, publishers send a message to a topic, which is then received by subscribers who have a subscription to that specific topic. They then send the acknowledgement that they have received the message. Okay, so the PubSub connector consists of a gpub off-ramp or the sink and a gsub on-ramp or the source. As the name suggests, the gpub sync mainly allows you to publish, that is, to send messages to a topic and create a subscription that enables you to receive messages. Then we have the gsub on-ramp that allows you to receive messages from a subscription. Coming to the implementation, for the PubSub implementation, we used a Rust crate called Google APIs, which is nothing but a library that's generated from Google API using tonic build in Rust. Um, Yeah, so before we understand further, we first need to understand what exactly is Google API. So for that, we need to understand all of the terms that I've mentioned here. So first of which is protocol buffers. So protocol buffers are Google's language and platform neutral mechanism for serializing structured data. You can think of it like XML, but something that's simpler, smaller, and faster. All you need to do is define how you want your data to be structured once. Then you can use special generated source code to easily write and read your structured data to and from a variety of data streams and using a variety of languages. So protocol buffer is also called as the protobufs, is used to serialize structured data and is also useful in developing programs to communicate with each other over a network or for storing data. So when you run the protocol buffer compiler on a .proto file, the compiler generates the code in your chosen language. So currently we do not have Rust as one of the supported languages by Google for code generation from protocol buffers. Hence we are looking at these libraries and frameworks, and that's also because the entire code base of Tremor is written in Rust and we needed the implementation of the Google APIs in Rust. So now let's look at gRPC. gRPC is nothing but an open source remote procedure call framework, and it uses protocol buffers by default as the definition language and message format. Coming to Tonic, Tonic is a Rust implementation of gRPC, which is nothing but an open source general RPC framework. And Tonic is composed of mainly three main components, which one of which is the generic gRPC implementation. Then we have the HTTP2 implementation, and then code generation that is powered by Prost. So the code generation contains the tools that will allow you to build clients and servers from protobuf definitions. And then Prost is a protocol buffers implementation for the Rust language. Prost generates Rust code from the source.proto files using the proto2 or proto3 syntax. Um, its goal is to make the entire generated code as simple as possible. So an example of it you can find in this slide. We have the protocol buffers implementation of something, and Prost will help you generate the following Rust structure, which is the Rust implementation of that protocol buffer. Okay. Tonic build is the code gen or the code generation module of Tonic gRPC implementation. It compiles proto files via Prost and generates service stubs and proto definitions for use with Tonic. So Tonic build was something that was used for the generation of Google APIs. That is the crate that we used for implementing our PubSub connector. Now let's come back to Google APIs. Through this, we now have the Rust implementation of all the Google APIs, including what we need, which is Google PubSub service. Okay, let's come to the walkthrough guide. So similar to GCS, you'd need a service token JSON file and a PEM file here as well, since we'll be using a service account. You'd need an outbound and inbound trickle file as well. Again, you need the YAML file. An example of how gpub can be configured is as shown. If you use if the use case for the off-ramp requires metadata from the Google Cloud PubSub service on the supported operations for this off-ramp, then you can also set link to true and configure the output port out. If the use case does not require metadata, then you can also set link to false. Okay, an example of the request and response received on sending a message via the gpub sync is shown in the slide. So for sending the message, you need the GCP project ID, the name of the project to which it's being sent, and the data or the actual event that has to be sent. Then we have the ordering key. The ordering key is useful when you want the messages to be received in a specific order in which they are sent. Then in the response, you get the message ID that's assigned by the Google Cloud PubSub API. Then the GPub sync also allows you to create a subscription to a PubSub topic. So while creating a subscription, you would also have the option to set message ordering to true to receive all the messages in order. The format for sending the request is also shown. Um, yeah, and receiving messages in order might also increase latency. So for a complete detailed description of all the terms that are involved, you can refer to the docs. The response you get includes all the details of the created subscription, including the acknowledgement deadline, which is in seconds, the topic name, and if you have enabled message ordering or not, etc. Okay, so for GSub, an example of how the YAML can be configured is as shown. Again, the preprocessors codecs are configurable. You'd also need the name of the subscription that you're going to receive all the messages from in the YAML itself. As you can see in the config, we have the PEM, which is the GCP PEM file for certificates authentication. Then we have the subscription, where you need to enter the name of the subscription you're going to receive the messages from. Um, then the GSub definitely allows you to receive messages. So the response for receiving a messages looks something like this. You get the data that which is the actual message, and we also get the metadata as response that includes the message ID and the acknowledgement ID of the message. All you need to do is configure the inbound trickle to display the metadata also along with the message when you're receiving a messages via the source. The use cases of this project. Okay. So some of the possible use cases of the connectors includes events and logs can now be easily stored in GCS, which is a use case of the GCS connector. Then the open telemetry logs, traces, and metrics can now be distributed over PubSub, which is a use case of the PubSub connector. There are definitely more use cases which are now being looked at with here. So now I'll be talking about my experience contributing to Tremor as an intern. Yeah, so I'd say that the Tremor community is absolutely great. As I was contributing to it as a part of my internship, I was definitely very lucky to have direct access to the Tremor developers who were working at Wayfair whenever I had any questions. We used to have a lot of meetings in the general voice channel on Discord with the Tremor developers, and anyone could join in and ask questions, discuss ideas, and share what they're working on. This definitely used to be super helpful. Apart from that, we also used to have office hours, which were really fun. And yeah, it was an overall great journey contributing to Tremor. I learned so much in these 3 months' time with the support of my mentors. And I'm very grateful to CNCF for organizing this mentorship program as it gave me the opportunity to learn about different things like event processing, distributed systems, Rust, cloud native technologies, etc. I'd say I wouldn't have learned so much in these 3 months' time had I not been a part of this mentorship program. It was definitely a fun learning experience, and I'd recommend you to apply to it if you get a chance, for sure. Last but not the least, I would like to thank all the mentors, Derek, Heinz, Matthias, for being super kind and always encouraging me to ask questions and clarifying all my doubts. Also, thanks to Anna and Natalie for all their support and guidance. They're all amazing. That was all from my side. Thank you, and I hope you enjoy the rest of the TremorCon.
Well, that was our second talk, not our second thought. I can't speak anymore, and we are only 2 talks in. This is going to be a great day. First of all, thank you, Jigyasa, for this awesome talk and for joining us on the Q&A. For those that haven't figured it out, to my right, I have to point to the left, this is so confusing, is Jigyasa, who is kindly enough going to answer a few questions. So let's start off with something really simple. Um, give the people in the chat a quick intro. Who are you, and what the hell did you do with Tremor?
So, yeah, of course, my name is Jigyasa. I recently graduated with, doing my bachelor's in computer science, and I'm currently working as a software engineer at Amazon. Apart from that, I like doing music in my free time. And yeah, I contributed the GCS connector and the PubSub connector to Tremor, which was pretty amazing experience overall. Yeah.
Nice, nice, thank you. So I'll ask you the same question we asked Nooper because it's super interesting for us and probably for some of the, hopefully for some of the viewers as well. Why Tremor? It's not Kubernetes yet. It's a fairly small project. So when you looked at the CNCF mentorship offerings, you
Yeah.
obviously choose Tremor. So what made you pick us?
I think one of the interesting things about it was the entire code base was written in Rust. So I wanted to try my hands at Rust. And apart from that, I really liked the community support. I had joined various Discord channels and the Slack channels of various communities, but I really liked how helpful and how involving this community was. And I liked the overall community support. So I wanted to go ahead with this project.
Yeah, that's good feedback. Thank you a lot. So you said you were curious in Rust. I take it. Did you write Rust before you started with Tremor, or have you? Was it
Not at
just the
all.
first thingy?
No, not at all. I was not aware of it before, but yes, after starting the project, it was quite intimidating for me. I think it was a little difficult compared to other languages, but yes, it became easier by writing good notes and with the help of all the mentors, you, Matthias, and Derek. It was pretty amazing.
So that makes number 2 of our Rust converts. Or are you planning to never touch Rust again?
No, it's not like that. Of course, I'd love to contribute more to Tremor again in
Yeah.
future, but as and when
So
I
you're
get time,
enjoying Rust.
of course.
You said it was difficult in the beginning. What made you trip up, or what made it difficult for you?
Ah, okay. So there are a lot of things in Rust, for example, lifetimes and what else? And at first, I was not able to understand the errors that were there in VS Code as well. So it was quite difficult to understand what I need to find. And of course, there were not many resources for Rust online. So I had joined various Discord channels. There was this Rust community channel and another one that I had joined. So I would ask all my questions. I wouldn't hesitate. I would ask all my doubts and questions there, and I'd get help. So that was pretty great. Um, yeah, that was all.
That's good advice. And glad to hear that you found a way to get used to it. Let's throw something in which is a bit more related to your work directly on Tremor. Do you see any follow-up tasks that came out of your project, or is it all wrapped up and done?
So I think one of the follow-ups to the GCS connector could be streaming uploads to GCS, which was uploading an object in batches to GCS, which is yeah one of the follow-ups to it. And apart from that, I think more things can be enhanced in both of those connectors. Maybe we could enhance the code more. I'm not sure what else. I
Code
can't think
can
of anything
always be
else.
enhanced, right?
Yeah.
It's a constant cycle of writing, rewriting, and polishing. Things move. That's fine. Um, what was the biggest obstacle you found in your as part of this mentorship? What was the most challenging situation? And as a follow up to that, also, what advice would you give someone doing a mentorship on Tremor or really anything else that you would have wished you had when you started this?
Okay, so I think one of the biggest challenges was when I started with the project, I took one approach which eventually didn't work out, so we had to switch to another approach. So one advice to that would be just don't give up and don't feel that you won't be able to complete the project. Of course, you might think there's less time to complete the project, but you can always look for alternative approaches and work a little more harder, and of course you'd be able to complete it on time, and just don't give up.
That makes a lot of sense. It's good advice to never give up. And in programming, in usual, it happens that you run into a dead end every now and then. And it's
Yeah.
important to recognize that and keep moving on in a different direction then. So you implemented two parts of this, or two sides of Google Cloud. That is Google
Yeah.
PubSub on the one hand and Google Cloud Storage on the other. And you had to take different approaches there. You did one over gRPC and the other over JSON, right? How did those two approaches or those two interface types work for you and compare? Was one thing was easier, harder, more interesting, less interesting?
Okay, so I think the approach, which was the gRPC approach that I followed while implementing the PubSub service, was a little more easier and quite more interesting than the other one because the GCS approach used the normal RPC framework that we generally use, the HTTP one. While on the other hand, I got to learn a lot while implementing the PubSub service and more about code generation, Tonic, Frost, and what else. So I think it was interesting because I got to learn a lot, and apart from that, it was, I would say, a little more easier also to implement. So that was a good thing.
Yes, it's always a good thing if something works easily.
Yeah.
So before we go into letting you talk a minute or two, because we're running out of time, a minute or two about yourself and what you're doing right now. One last question. After the mentorship, since we talked about some opportunities left in GCS and PubSub, will you be around for people that want to take those tasks on to help them and perhaps become a mentor now that you have been a mentee?
Of course, I'd definitely love to help, and I can also give maybe a technical explanation of what I worked on in more detail to someone who would like to take this up, because there's already an open issue for streaming uploads to GCS, so someone can definitely take that up. Yeah, apart from that, what else was the question? I don't remember.
Basically, if you are going to be around for people to ask if
Of
they
course.
want to work on the follow-up tasks.
Sure. Yeah, definitely.
One last question before the stage is all yours. What would be your number one advice for mentees or people looking for mentorship in general? And you notice this is its theme. That want to take a mentorship, be it Tremor or somewhere else. What is the number one advice you would give them?
I think, first of all, the first and foremost thing is just don't hesitate. Don't hesitate to ask questions. Ask as many questions as you want to, as many doubts as you have, and yeah. Apart from that, you should for sure try try your hands at open source, contributing to open source, because there are a lot of mentors out there who are there to help you out. So just ask your questions, even if you think it's a silly doubt. Just go ahead and ask, and yeah, that's all.
That's wonderful advice. So last, before we go into our next coffee break, anything you want to tell the viewers what you're doing right now, what you're working on, something interesting to share which they can follow or look at? Anything you want to share?
Okay, so as I mentioned, I'm currently working as a software engineer at Amazon. So I've recently started, so I don't have much to share about it, but I can talk about what I would be working on. So there's this page called Manage Your Subscriptions on Amazon.com. If you go to that page, you can manage all your subscriptions you have for Amazon. For example, Kindle Prime, or you could say Audible. All of the subscriptions can be managed from one single page. So I'm a part of the team that handles all of that. I'm currently working on that. Apart from that, I like to contribute to open source in my free time and make music.
That is really awesome. So your work is literally touching probably everyone's life, since we all have Amazon subscriptions. So for your next talk, will you make a jingle, since you like making music?
Sure.
I'll hold you
I'd
to
love
that.
to.
If you're talking
Okay.
TremorCon 2021, you got to make a jingle for your talk.
So I do that.
Jigyasas, thank you so much for your time and the talk. It was awesome having you.
Thank you.
And with that, we are going for another coffee break because it's still early-ish in Europe. Well, it's actually noon, but you can't have enough coffee ever. And we will see you in about 50 minutes. 15, sorry, 1-5, not 50. 15 minutes with Rohit talking a bit more about property-based testing. See you all around. Bye-bye.